So are you doing your work? No? Feeling exhausted? Maybe you do not have enough energy. I want you to not only do this work but also finish it within 10 minutes. God bless you with that power. You must have heard about these terms work, power and energy. They are frequently used in our everyday language. So what physiological picture do these terms generate in our minds? Let us discuss about these terms one by one. So first of all, let us talk about work. Who is said to be working? A farmer, a construction worker, a student or a painter? Now this physics subject is really merciless. It says that work is said to be done by a force on a body over a certain displacement, which means that only if a force which is acting on a body and that force is able to cause a certain displacement of the body, only in that case the work is said to be done. That means that this definition of work in physics is really very precise. Next comes the energy. When you say that you do not feel enough energy, what does that mean? It is directly related to something called stamina. You lack stamina and you say that you are feeling exhausted, you do not have energy. So another meaning of energy can be the capacity to do work. And what sort of work? Only that work whose definition is governed by physics. Force, displacement. So if a person is able to work for 14 to 16 hours in a day, we say that the person is having a large stamina. So this is what we mean by energy. So in physics also energy has similar meaning. Now let us talk about power. Now somebody is doing boxing and his coach is standing nearby and he says और जोर से मारो, जोर लगा के मारो, पूरी ताकत से मारो. That is what we mean by power. ठीक है? तो power is something which is delivered, a force delivered at a greater speed, which are punches in the present case. You want the punches to be delivered at a greater speed. So this is what we mean by power. So in physics we are interested to not only know the work done but also the rate at which this work is done. For instance, if I want to call a person as a physically fit person, so I'll say that he is not only able to climb 4 floors of the building but he is also doing them fast. Rate of doing work. Time कम लेना उसी काम को करने में means that you are having more power. So power can be defined as the rate at which the work is done. Now these are the definitions of work, power and energy that we have just discussed. Now before proceeding further, before going further and knowing the exact expression of work done in physics, let us talk about vector multiplication. There are 2 ways, the scalar product and the vector product. The outcome of a scalar product is a scalar and the outcome of the vector product, the multiplication of 2 vectors by the means of a vector product, is a vector. So for the definition of work, we will be only interested in this scalar product, which is also known as the dot product. And what is that? A dot B is AB cos theta, where A and B are the magnitudes of vectors A and B respectively, and theta is the angle between the vectors A and B. Now if you observe this expression carefully, you will notice that A dot B is nothing but AB cos theta, the magnitude of A into B cos theta. So what is B cos theta? It is nothing but the projection of vector B onto the vector A. So this magnitude B cos theta, when multiplied by the magnitude of vector A, gives you something called the dot product. The resultant will also be a scalar, or you can interpret it to be BA cos theta. BA cos theta is nothing but the magnitude of B, and which is multiplied by the projection of A onto B, and both will be having exactly the same value, which means that the dot product is commutative, and this distributive property also holds for the scalar product. And if you consider the unit vectors along x, y and z directions, which are I cap, j cap and k cap respectively, you will notice that the following properties hold, because for 2 orthogonal mutually perpendicular directions, this dot product will always be 0, because in perpendicular direction there will be no projection of one vector onto the other. Cos theta, cos 90 degree is 0, cos pi by 2 is 0, and for 2 vectors A and B, the expression of the 2 vectors when multiplied by the means of dot product, you will get this resultant, and if a vector is multiplied by itself, the dot product will be this. So as already discussed, if A vector is perpendicular to B, your cos theta, cos pi by 2 will be 0, and you will not get any projection of one vector onto the other. So that means that for two mutually perpendicular vectors, the dot product, the scalar product will be 0. So now that we know something about the dot product, let us now go back to the definition of work, which means that force, displacement, and work is nothing but the dot product of force and this displacement, which means that work is F dot d, and this can also be written as Ft cos theta, where theta will be the angle between force and displacement vectors. So now you are familiar with the expression of work in physics. Okay, now let us find out whether there is some relation between this work and energy. Any sort of relation? You must be familiar with the kinematic equations of rectilinear motion with constant acceleration. I choose one of these equations. Okay, so let us now see the magic. You only need to multiply this entire equation by m by 2, half into mass, and see what do you get. The term on the right hand side is mass into acceleration dot displacement, and you know that mass into acceleration is nothing but force. So force dot displacement, and this is nothing but the definition of work. So you can write this as work. Now let us take a quick look at the terms on the left hand side. You will see that these are nothing but half m and speed ka square, half mv square, and this seems to be familiar with something called kinetic energy, and you now know that v is the final speed and u is the initial speed. So half mv square will be the final kinetic energy and half mu square will be the initial kinetic energy, and the difference between the two will be the change in kinetic energy, which means that work done is nothing but that is equal to the change in the kinetic energies of the body. Now since you know that the work and energy, the work and the change in kinetic energy, these are related by this equation, which means that the work and energy will have same dimensions and both are scalars as well. So you now know that work done is nothing but the component of the force vector along the displacement vector and the magnitude of displacement, the product of these two. So this simply means that despite of you providing a certain force on a body, and if that body is undergoing no displacement, no work is said to be done by the definition of physics. For instance, consider this to be a wall. This is not a wall, this is a door which I have opened to its maximum potential. So if I push against this door, so if I am pressing hard against this wall will undergo no displacement. So despite of me feeling tired, I'll say that I have put in a lot of effort, but my energy, my internal energy is getting consumed up. So I'm feeling tired. The muscles are relaxing and contracting. However, by the definition of physics, I have done no work on this wall. I have not been able to push this wall to a certain distance, so there is no displacement, and despite of me putting in a lot of effort, no work has been done. This is why I say that physics is merciless. So which simply means that work done is 0 if displacement is 0. Another example can be a weightlifter carrying a weight, a heavy weight on his shoulder for some time. So since he is standing in a still position and there is no resultant displacement of the weight that he is carrying, he is standing still. So in the definition of physics, no work is done on that object, on that weight by the bodybuilder. Second will be when force is 0. Now though this will be hard to imagine, but you have to consider a hypothetical surface which is very smooth and no friction is there. So when an object which is already moving, this object will continue to move over this smooth surface since there is no friction to oppose this motion. So in this case, if the force is 0, though there is a net displacement, even then there is no work done on this object that is moving. So here displacement is there, no work is done. So the last case when work done will be 0 is when the force and displacement are perpendicular. So in that case also the cos pi by 2 will be 0, cos 90 is 0, so no component of either vectors onto the other. So in that case also the work done will be 0. For this case, the example can be if an object is moving on a table. So if an object is moving, the gravitational force is acting downwards. The weight mg is in the downwards direction, and the displacement, this displacement is exactly at right angles to the direction of the gravitational force. So if you were to calculate the work done by the gravitational force, so that will be 0, because it will always be at right angles to the displacement. So gravitational force is doing no work. However, if you are providing some force along the direction of the displacement, that external force is doing work in this case and not the gravitational force. Another example can be the orbital motion of the moon around the earth. And you can assume that if this orbit is exactly circular, though it is not, so in that case also the gravitational force of the earth is doing no work on this moon, because instantaneous displacement of moon will always be tangential. Because instantaneous displacement of moon will always be tangential to the force of the gravitational force of the earth. It is also to be noted that work done can either be positive, negative or 0. When the cos theta values are positive, the work done will be positive, and for negative cos theta values, work done will be negative, and for 90-degree case, it will be 0. So the SI unit of work and energy is joule, named after the famous British physicist James Prescott Joule. So here are some alternate units of energy expressed in terms of joules that are also used. Now let us move on to the last term, which is power. And now you know that work and energy are interrelated. Okay. And the definition of power was rate at which work is done. So I can add another thing to this definition, which is rate at which energy is transferred is also power, because work and energy are interrelated. So now let us talk about the expression of power. Power is rate of doing work. So this will be average power, which is work done by total time. T is the total time. Now if you want to talk about instantaneous power, the power at a particular instant, so that will be dw by dt, where this time interval dt tends to 0. dw is nothing but the work done by a force over a displacement dr. If a body undergoes a small displacement dr by a force F, and the work done will be dW. So you can put this expression in the numerator, which is F dot dr. So this is F dot dr over dt. So which means that F dot V will be the expression for power, because dr by dt is nothing but velocity. Power is F dot V, the dot product of force and velocity. So some quick points about power can be like energy and work. The power is also a scalar quantity. Next is the dimensions. Dimensions of power are nothing but the dimensions of energy or work divided by time. Rate of doing work, the rate at which energy is transferred. So if you know one of these, you simply divide it by time. So you will add another time inverse, so you will get this dimension. And the SI unit of power is watt. 1 watt is 1 joule second inverse. Watt is named after James Watt, one of the biggest inventors of the steam engine in 18th century. Another unit of power is the horsepower, and this unit is used to describe the output of automobiles and motorbikes, etc. When do you come across this term watt? Whenever you purchase some electrical goods like bulbs, refrigerators, etc. or heaters maybe. If I ask you to tell me about the energy consumption, if a 100-watt bulb is used for 10 hours, it's switched on for 10 hours, how much energy will be consumed? So when I'm talking about energy, which means that this is something related to work done, and you know that power is rate at which energy is transferred. So simply I've given you the amount of power and the time for which that is used. So power into this time interval. So power into this time will be the unit of energy. So 1 kilowatt hour is the unit for that. Take a look at your electricity bills. The unit that will be there will be the units of energy, and that will be in kilowatt hour. So it is to be noted that kilowatt hour is the unit of energy and not of power. So that was all about today. I hope you are now familiar with these terms, work, power and energy. I'll be back with my next video. Toodles.